I'm Jonathan Tomkin from the University of Illinois. If the ecological footprint idea is too crude to help us with a policy debate, which is where it would matter, where we would decide on changing a process, perhaps by using a more specific footprinting idea, we can actually make more progress in moving towards a sustainable future. So one example of a more specific footprint idea is a carbon footprint. Carbon footprinting is kind of a funny term actually, because really when we talk about our carbon footprint, the meaning, and sometimes it's contested, but I'm going to use this definition here, our carbon footprint measures the total greenhouse gas emissions caused directly and indirectly by a person, organisation, event or product. If we think about that, that doesn't actually involve a land area. So why are we using this footprint terminology? And I think that's because of the importance of ecological footprinting in this idea of measuring our environmental progress. And so indeed we see this footprinting idea come in many other areas, for example, energy footprinting. So footprinting has become very much a metaphor. It already was a metaphor, of course, because it's a footprint. That's a metaphor for our impact on the land, and now it's another step removed from that, so to speak. A further confusing thing about a carbon footprint is it's not just carbon. It's actually a greenhouse gas footprint. But we can use other greenhouse gases, like methane, for example, and turn them into carbon equivalents. And so by adding together our other impacts, so for example, methane from farming, we can add that in and get a single number, which is the carbon footprint. This concept is used for individuals, for companies, for countries, and we can see here an example of different processes. In this graph, we're looking at carbon emissions for electricity generation for different types. And we can see here that coal in 3 different countries has a much higher carbon footprint than gas does, or renewable energy sources do, or nuclear does. We can also do this for different countries. The United States is famously high in that it has a lot of carbon dioxide emissions per person. If you look at this graph and you have good eyesight, you might be able to find your own country and see how you compare. And we can also use this idea for individuals. So we can measure our own carbon expenditure and then determine our own carbon footprint. That is how much carbon dioxide we put into the atmosphere each year. In the US, most of this carbon footprint is directly in the form of energy use. But actually that leaves a lot out, right? What's that other half? This is where we get to see that although carbon footprinting is a relatively clean measure, it's relatively straightforward, although there are complications to do with what if we try and do carbon offsetting, or we have forests or regrowth and so on. But there is a problem in that many of the things that we use have carbon dioxide emissions hidden within them, just in the same way that we saw that foodstuffs would have large amounts of virtual water hidden within them. The equivalent terminology and idea for energy is embodied, or sometimes embedded, energy. This is the sum of all the energy required to produce goods or services, considered as if that energy was incorporated or embodied in the product itself. So for example, buildings have lots of embodied energy in them. It requires a lot of energy to make steel, aluminum, brick, concrete. In fact, if we look at the entire life of a building, about half of the energy in its use is not actually from the heating, the cooling, the lighting, it's just from the building and the manufacture. So when we think about our own carbon footprints, it's not just a question of looking at how much gas we use or how much oil we consume, it's also about other products that we use that needed energy to be made. So to do a full assessment then, we need to look at the complete life cycle of a product. Life cycle assessment is a way of measuring things like the amount of energy used, so in any sort of footprinting analysis, be it water, energy, carbon dioxide. But we have to look at it from every step. This is sometimes known as cradle to grave analysis because it looks at its manufacture, its use, and what happens once it's disposed of. There are 4 classic steps. First, you have to consider the acquisition of the materials. So for example, the energy required in mining or in recycling. We have to worry about the manufacturing, refining, and fabrication of that object. We have to worry about the use by consumers. And then finally, we have to worry about how much energy, carbon dioxide, water and so on is required to decommission that object. For most things, life cycle analysis really only focuses on one or two steps because they often dominate, which is the most important. So for example, for a car, it turns out that the end use is the dominant factor in determining its energy output. Manufacturing and fabrication does take up a significant amount, but compared to the oil or gas that's being used to drive the car, it's relatively small. On the other hand, if we talk about an aluminum object, so a can, for example, of soda, it's actually the first two steps that are most important. Lots of energy is needed to extract the bauxite, and even more energy is needed to turn that mineral into aluminum. So when we do a life cycle analysis, we can capture all of these ideas. And life cycle analysis is now pretty much the standard technique used by people who are trying to measure the sustainability of their products or processes. And so in the textbook, you will see lots of detail about how different people and different companies use this idea to measure their impact on the environment. If you do peruse the textbook on life cycle analysis, you'll see how complicated it is. There are many steps and there are many assumptions that have to be made. Couple this with the knowledge that there are literally millions of different products in the world today, and of course billions of consumers, we can see that accurately calculating the life cycle impact of any object is actually quite difficult, and in some cases highly contentious. If you're relying on estimates that aren't simple, so in other words you have an object that is used and then recycled and then used again, where do we draw the line? Where does the fabrication stop and where does the use of the next object begin? Or the knowledge that some objects are wasted. So on some estimates, a quarter of food in developed countries is not used for eating, it's thrown out or it's wasted in other ways. You can clearly see that actually this becomes quite a complicated calculation. So in practice, professionals are consulted when life cycle analyses are required. And there's actually a new field called sustainability consulting, where experts will go and try and determine these processes. If you need to be a professional to do this, where does this leave the individual? If you and I wish to have a lower footprint, be it ecological or otherwise, how do we decide to do that? Well, it's very complicated. We use some ideas, we use some simple rules of thumb, but these can sometimes mislead us because of the abstract nature of environmental impacts. In the next lecture, I'll use food miles as an example of how the individual can find it quite difficult to determine their own impact on the environment.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.